We probably all have had some bad experience with teachers that either gave really boring classes or very inefficient classes. But we, of course, don't want our virtual teachers to act the same way, right? For collaborative learning, we need the teacher to exhibit human-like behavior, as this increases the engagement and the learning outcomes of the students. But how are we going to do this? Because, for example, with emotions, how are we going to model how the tutor will exhibit certain emotions in certain scenarios? Because it is very dependent on the student. And if we also are going to embody these agents in robots or avatars, then there are some other complications. Yeah, modeling human-like behavior is very difficult because human behavior is complex and it's different for each person. And as well, our teacher has to know how to act, but also how to adapt to different students. And this is where human demonstrations come in very handy, because you know how humans act in many different scenarios. But human data sets are often very challenging because there's often imperfect behavior. Just like, for example, today, if we want to train a person how to work with the audio equipment and that everything works, we don't want we don't want stuff like this to happen. So that's a problem. So we have to be able to deal with that. And on top of that, yeah, there can be gaps or there can be missing data, and the coverage can be limited as well. So this is where my method, brace yourself, mixture of autoencoder guidance using unlabeled imperfect data for exploration comes in. I will keep it to MOE guide because otherwise it will be way too long. So what we do is we train a supervised model on a bunch of human-like data. So for example, we have a lot of videos and we train it on each frame of the video, and we try to make it predict how similar each new sample that it gets is similar to human-like behavior. So when we have that similarity, we map it to a reward. And we use this reward as an auxiliary reward on top of the task rewards that the agent gets. And this way, we guide the agents towards regions that have human-like behavior, but we don't force it. For example, if the human-like behavior is like here with the audio, then we don't force it to do it the same way, but we allow it to adapt to be more efficient. And by doing this, our model is both able to deal with imperfect data as well as incomplete data. So now I will first go into a bit deeper in the design choices of MOE Guide, and then I will show some results under imperfect expert and with very limited data. So there are a couple of ways how you can model human-like behavior. One is behavior cloning, and here you just use the data set that you have of human-like behavior, and you try to find patterns in it on how to act human-like. There are a couple of problems. You need a very high-quality data set that covers a lot of different scenarios. And you are also, it's very hard to outperform the human expert that created the data sets. And then on the other side, you have reinforcement learning. And this agent learns through interaction with an environment. So you don't need the data set at all. And by doing that, it's able to outperform a human expert. But it has a big disadvantage that now you need to model all the human-like behavior in the form of rewards yourself. So you have to define yourself, if I act like this in this situation, that's good or bad, which is very difficult. So why not combine them? As you might have noticed during the talk, both of the pros of the other methods counter the con of the other method. So if you combine them well, you probably can have a method that has none of these cons. And that's exactly what MOE Guide tries to do. So we evaluated our method in an environment like this, where we have a robot in a realistic physics engine that has to perform a certain task, and then we give it an extra reward to act similar to a data set that we provided MOE Guide. So now we'll go over to some results. So when we see with an imperfect agent, on this chart, you can see that the rewards that are shown are relative to the expert. So the expert has a reward of 1 here on the graph. And then normal reinforcement learning is quite a bit worse than the expert, but then the baseline that we have used of the state-of-the-art method, it's only able to outperform it by a little bit, while our method is able to outperform it quite a lot. And this allows us to improve on imperfect behavior quite well. And then our method is also very good at dealing with very limited data. So the result that you saw before was with only 20% of the data. So that means that we had one sample, then the next 4 samples we discarded, then we used the next sample, and so on. So it only used 20% of the data, and then even with that, we see that we can outperform the expert by quite a lot. And then we went even further, and now we took one sample and thrown away 24 of the next samples, and then took the next one, and so on. So it was very sparse data, but our agent still was able to learn a lot from it because we only had like a small drop in performance. So to sum up, MoE is able to work with limited data, imperfect data, and incomplete data. And these are exactly the challenges that you have with human data sets. So to summarize the presentation, we need AI tutors to have human-like behavior. And by showing by MoE Guide, we can do that even with the challenging human data sets. And this way we can support students more naturally and by acting more reasonable like humans and moving more human-like. And this hopefully will improve the engagement and learning outcome of the students. So MoE Guide is one step forward to having more human-like teachers and training partners so that students hopefully don't have the same experiences that we had with tutors that are boring or inefficient classes.